All right, number 48. Okay, we're given what the way these resistors, these light bulbs are described to us. We're told that they are 60 watt, 120 volt light bulbs. 60 watt, 120 volt light bulbs. So what that means is this. These light bulbs will be 60 watt when they're connected to 120 volts. Okay? But you look at this diagram, so basically they're telling us that we have 120 volts put in here. So this diagram is like this. So here's what they're doing. Basically, we have a battery in here of 120 volts. But look, will the delta V across this guy be 120 volts? It's not 120 volts. We have to figure out what it is. So look, the first thing you got to do in this problem is you got to figure out what is the resistance of the bulb, of these bulbs. So it's like this. If you took one of these bulbs, so there's the resistor, and connected it to 120 volts, the power would be 60 watts. Is that enough to figure out the resistance? Yeah. It is, because you can use one of the power equations, P equals delta V squared over R. So R is going to be equal to delta V squared over P. So the resistance of one of these bulbs, when the bulb is hooked up to 120 volts, the power is 60 watts. So this simplifies to 240 ohms, right? So each of these bulbs is 240. That's the first thing you got to do, is find the resistance. You guys, does that make sense? Yeah. Okay, so we're basically dealing with 240 ohm bulbs. Okay, so you know what? I'm going to scrap this. I'm just going to redraw this whole diagram. So get rid of that, and here's what we got. We got 120 volts. So here's the battery. 120 volts. 240 ohm light bulb. And then over here we got 240 ohm light bulb. And then over here we got 240 ohm light bulb. This is our circuit. There's 3 currents here. So the current out of the battery, I'm going to label that I. And then what happens at that junction? That current breaks into I1 and I2. And those are going to be equal. I1 and I2 are equal because the resistances here are equal. You know? Okay, and then here we're back to I. All right, now the key to circuitry is to draw simplified pictures. Don't even try to answer the question until you've simplified things. All right, so what we're going to simplify now, I'm going to shrink that down. We're going to simplify these guys. The 240s, they're in parallel. So you do the 1 over equation. So this is going to become, so there's our 240 right there. And then the 2 parallels, these guys simplify to 120. Okay, so this is 120 volts. The current flowing through here is I. It's the current out of the battery. And then our final picture is going to be this. So we have 2 resistors in series. So this is going to simplify to 360 ohm. 120 volt with a current of I. That's the current out of the battery. All right, so what you do, you start at the most simplified picture and you work your way back. So for example, let's start by figuring out what I is. What is I going to be? Well, how many volts are across this 360? Well, 120 volt battery means 120 and 0. So right here we got 0. Up here we got 120. So how many volts are across that 360? 120. So you go, okay, delta V equals IR. I is delta V over R. We got 120 volts over 360 ohms. So that gives us 0.3 repeating. So basically it's 1/3. 1/3. So I is equal to 1/3 1/3 of an amp, which means we have the current here. This is 1/3 of an amp, and then right here, 1/3 of an amp. Okay? So now, I think we're ready to solve. Okay, so they want, first question, what's the total power delivered to the 3 bulbs? So you could do it the hard way or the easy way. The hard way would be to calculate the power of each of these guys and then add them together. You could do that. But then what would be the easy way? The easy way would be to go to this guy and find the power, right? Because who is this guy? Who is this 360 down here? It's the whole circuit simplified. It's all 3 resistors simplified. So let's find the power. Let's find the power of this 360 ohm resistor. So which power equation could we use? We could either use I squared R, or we could use delta V squared over R, because we have everything. You'll get the same answer, right? So let's do I squared R first. P equals I squared R. The current is 1/3 of an amp squared. Resistance is 360. So this gives us 40 watts. If you do delta V squared over R, that's going to be 120 squared over 360, and then that also gives 40 watts. Okay? So the answer to question A is 40 watts. Okay, B. What's the potential difference across each one? Okay, here's the easiest way to do it. So start here. Let me make this picture bigger. I'm going to blow this up. All right, 120 volt battery. That means 120 and 0. So right there, we got 120 volts. Now, this current right here is 1/3 of an amp. So can we find the delta V across this 240? Yes. Yeah, you just go I times R, right? Delta V equals IR. So that comes out as 80. The voltage across this guy is 80. So how many volts are we going to have right here? 40, right? 120, we lose 80, which brings us to 40. Okay? Down here, we got 0, 0, 0. And then this point right here would also be 40. So how many volts are across this guy? We can see it pretty easily. 40 to 0. How many volts across that dude? 40. How many volts across that dude? 40. 40 to 0. Okay. And then look, final comment here. For any complete loop, you should know as you go around a circuit, the voltage gain equals the voltage loss. A big mistake that students make is they're like this. So you cross the battery here, how many volts do we gain? 120. But then when you go through the circuit, we have 80, 40, and 40. So 80, 40, and 40 is 160. So I've heard it many times where students are like, Spaldo, I thought voltage gain equals voltage loss. And I'm like, that's right. And they're like, well, what's up? We got 120 and then 160. You know what I'm saying? So that's the wrong way to think about it. Look at the way you got to look at it is there's 2 possible loops here. So you cross the battery, you gain 120. You could loop this. That'd be one loop, right? Voltage gain is 120. Voltage loss is 120. What's the other possible loop? The other possible loop is over here. Gain 120, lose 120. So what I'm saying is don't, when you're doing voltage gain equals voltage loss, don't count the voltage of the parallels twice, because you can only loop one at a time. You can't loop both simultaneously.